Now let's take another example. There are three identical point charges. Remember, if there are point charges, we can use Coulomb's law like K, Q1, Q2 upon R square. And these point charges, they are forming an equilateral triangle with side length L. All three charges are identical, Q, Q and Q. We need force on this charge by these two charges, Q and Q. What we can do is, force on this Q is coming from this Q, and both are positive, and therefore this Q will repel Q in this direction with the force of F, and this F is given by K Q1 into Q2, which is Q square divided by L square. Similarly, force coming from Q, since we are having same separation of L, we can say that this force is also of the same magnitude F, which is nothing but K into Q square divided by L square. So these are the two forces coming on this third charge Q from these two charges, bottom charges Q and Q. If we need total force, that total force is what? F plus F, which is what? 2F. But now there is a problem. We are dealing with vectors, and if you are dealing with vectors, we cannot do something like this. You cannot simply add their magnitudes. You need to take care of their directions. These forces are not in the same direction, and therefore we cannot find total magnitude by doing this. Instead, what we do, this setup is an equilateral triangle, and therefore this angle is what? 60. If this is 60, this angle is also 60 degrees. And therefore finding total force, we'll use the vector method. And vector method says there are two vectors, F and F, making an angle of 60 degrees. Total force is given by magnitude of first vector square of that. Magnitude of second vector square of that, plus 2 into first vector multiplied by second vector multiplied by cos of angle between the vectors, which is 60. So this gives us F square plus 2F square, and cos 60 is what? 1 by 2. That gives us 3F square, which is root 3F, and then put the value of F, which is K times Q square divided by L square. We cannot do this. You cannot add directly their magnitudes. We'll use the vector approach, which says root over A square plus B square plus 2AB cos theta, and that gives you total magnitude.